So in this video, we'll be solving June 2017. And the first question is a question on quadratic, but this time around, as opposed to other natures of root which we have to deal with so far, which is only one in the case which was real and equal root. This time we're dealing with real and distinct, or real and different root. Both are the same as well. So in the first part of the Roman 1 of question 1 of 2017, we have to solve for values of k for which the root of the quadratic, so the set of values of k for which the root of the quadratic equation x squared minus kx plus 2x plus k minus 2 equals to 0 are real and different. Now, in this case, what you need to ask yourself is first of all the condition for the root of a quadratic equation to be real and different, or real and distinct, as the case may be. Now, real and different and real and distinct, the condition are all the same because distinct and different means something. So it is the discriminant, which in this case b squared minus 4ac equal to 0 for real and equal, and we have b squared minus 4ac being greater than 0 for real and distinct. Now again, this is another inequality, and now just take a little bit note of this. They're already asking about a set of values, that is, you're asked to give range, so it should be clear to you that this is mainly inequalities. Now, so from this our equation here, I'm going to look for the value of the discriminant, in this case, which we're going to have. Let me just rearrange the equation which we have from the question. It's going to be x squared minus plus 2 minus k into x plus k minus 2. Okay, so this is the question that we have rearranged here. Now if we now to take the discriminant, we're going to have 2 minus k into 2 minus k, which is the b squared, minus 4 into 1 into k minus 2. And do not forget, this has to be greater than 0. Okay, so we'll get, sorry, here is supposed to be a k, apologize for that. So we're going to get a 4 here minus 4k plus k squared minus 4k plus 8 greater than 0. So we have k squared minus 8k plus 12 is greater than 0. So the next thing here will be to factorize this quadratic, because we have a quadratic equation. To solve the quadratic equation to get the critical values. Okay, now in doing this, we're going to do this by factorization method. So we're going to have, this implies that k squared minus 2k minus 6k plus 12 is greater than 0. So factor everything out, k into k minus 2 plus 6 into k sorry, here we're supposed to have a negative sign, so let me just write everything again. K into k minus 2 minus 6 into k minus 2 minus 6 into k minus 2 greater than 0. So what are our critical values here? Our critical values here are going to be k equals to 2 and k equals to 6. So k equal to 2 and k equal to 6. So from here, we just need to get the table with some values. Well, this is the general table we should usually use for inequalities. So what we're going to do now is, for the value of k which are less than 2, we can work with 1 in this particular situation, and we're going to have a negative value here, another negative value here, and multiplying negative and negative or dividing will give you a positive value. And here, a number between 2 and 6, we can deal with 4, gives a positive, negative, negative. And again here, we're going to have a positive because 7 minus 2 or 8 minus 2 is going to be a positive value, depending on the value which you're going to choose for k greater than 6. Here too, we're going to have a positive value, a positive value. Now remember, it is for real and distinct root or real and different root, and the condition is b squared minus 4 ac being greater than 0. So the values, the range we're going to choose here are those which are positive. So this and this. So either this or this. So we're going to have it's going to be represented like this. X of element of k less than 2 union x for k greater than 6. So it is for this range of values that we can have positive, that we can have values greater than 0 in our original equation.